Hi, welcome to another lesson at EDU Solutions Institute. Now, today we're looking at the CSEC physics syllabus on the principle of momentum. Now, our previous lesson, we dwelled into some calculations that involve the use of our motion equations, right? So now we're going to explore a little bit more on motion to the term that's called momentum. Now, momentum. What exactly is momentum? Now, momentum has to do with the effect that objects have while they are in motion. Now, when objects are moving, they have a tendency to always want to continue to move, right? So therefore, if you start to roll down a hill, it's very hard for you to stop because the momentum is what's keeping you going and going, right? But due to friction, due to resistive forces, then objects will tend to stop moving when they're moving. So the ability, that joy, that passion that objects have that keeps them to move is what we call momentum, right? So momentum is calculated, P, common P for momentum, is equal to the mass of the object multiplied by its speed or its velocity. Now, momentum is in a unit of kilogram meters per second. Kilogram is for the mass, meters per second is for the volume. Right? Now, a thing to note about momentum is that it is a vector quantity. And what does that mean? It means that it will have a direction. So therefore, if we say an object is driving to the right, it has a momentum that is towards the right direction, which signifies to be a positive direction. Because if we need to know the direction, we use a t-graph, that everything that goes to the right would be a positive direction. Everything that goes to the left will have a negative direction. If it's going up, positive, and if it's going down, negative. So we use that principle always to know what direction our velocity has, which will in terms means what direction our momentum has. Now, with momentum, because objects are always moving with momentum, then there's a tendency to always, or occasions, going to collide. So therefore, we look at two principles or two types of collision, which is elastic and inelastic collision. Now, elastic collision takes into consideration of when the objects do collide, they will separate and move as separate objects. While with inelastic collision, the objects, when they collide, will actually continue to move as a one object, right? So therefore, it's not an elastic, it's inelastic. And with this, in terms of mixing with momentum, we look at the law that's called the law of conservation of momentum. And what the law of conservation of momentum tells us, you will see here on your screen, is that during a collision, the total momentum before collision is equal to the total momentum after collision, provided no external force is present. And what that means is, if an object is moving and hits another object that's moving, they both have two momentums. When you add that together, the number you get will be the total in that system. And therefore, after collision, even though one will probably speed up or slow down, when you add those momentums together again, you should get the same number as what you got in your previous before collision. So with that principle, then we can explore the two types of collision. So in terms of elastic collision, let's take, for example, a pool table. All right? And let's say we have a black ball here and a white ball here. The white ball is moving to the left with a velocity of v1. right? The black ball is stationary, it's not moving. Then after they collide, the black ball will move to the left. Let's call this velocity to v2, and the white ball will move back with a v3 velocity, right? So here we have that we know it's elastic because when the white ball hits the black ball, they both move as two separate objects. So therefore, in terms of the principle of moments, we will have that the total momentum, or the sum of momentum before the collision, would be equal to the sum of momentum after collision. And before collision, we had the black ball being at rest, so it has a momentum of 0. Because once you're not moving, you don't have a momentum because you don't have a velocity. Plus the white ball momentum, which would be the mass of the white ball multiplied by its velocity, which is a negative v1. Why is it negative? Because v1 is going to the left. So here it will have a negative velocity. And that would be equal, so this is before, would be equal to the mass of the black ball, now moving with a velocity of v2 to the left, so that's negative v2, plus mass of the white ball, and it's going to the right this time, so that's a positive v3. So therefore, what we have from this situation is that the momentum that the white ball had before collision would be the total momentum in this system, that when we add the momentum of the black ball here and the white ball here, you get back this same number that we have here. And what we'll use this for is for any situation of elastic collision, that the first thing we do is identify what is moving, where they're moving to, what is before collision, and what is after collision. And once we know that, then we'll be able to create our equation and then find our unknown quantity from our question. Now, let's look at this situation here. So let's say we have a little trolley A here moving with V1. It's going to collide with a second trolley that's also moving but at a slower speed, V2. Then after they hit, they're going to be connected together, moving with a velocity v. Alright, so in this situation, we always have sum of momentum before will be equal to sum of momentum after collision. And before collision here, we have both objects moving. So it would be the mass of A multiplied by its velocity, and it's positive because it's going to the right, plus the mass of B times its velocity, which is v2, because it's also going to the right. When we add those two momentum together, it will be equal to the sum of the momentum of these A and B moving together. So it's now mass of A plus mass of B multiplied by its velocity v. Alright, and therefore this velocity is sometimes referred to as the common velocity. The common velocity means the objects stick together and they're moving at the same unique velocity. And here we see that the total momentum before the collisions of A and B will be equal to the total momentum after collision, which is when we add A and B masses together and multiplied by the velocity that they're moving at. Alright, so here we have that for any different situation, we should be able to create an equation for the collision and use that equation to generate an unknown quantity based on the question. So in next week's lesson, we're going to explore these principles of using elastic and inelastic collisions to calculate unknown quantities based on the question that is being given. So thank you for watching. Hope you understand a little bit more on momentum. And I'll see you next week where we explore using these principles in practical questions. Thank you.